Welcome again to another example on the logarithm that I started with you in the previous videos. In the previous videos, we started applying the laws of logarithm that we've learned to solve some questions, and we've already solved many questions in the previous videos, and I hope you understood it and you enjoyed the lesson as well. So this is a continuation to solve another example with you so that you get a perfect understanding of it. So as you can see, I have some example on the board that I want to solve with you, and I will encourage you to do all to watch the previous videos because the previous videos lays the foundation. There are a lot of things that I've explained in the previous videos that we are going to apply here as well. So if you don't have any knowledge on the things that we've done in the previous videos, then you might struggle with this session. So please do all to watch the previous videos so that you can get a good foundation and understanding to be able to handle this session as well. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel. Let's go ahead and take a look at the question that I have on the board. So the question says that given that log 2 to the base 10 equals 0.3010 and log 3 to the base 10 equals 0.4770, find without using tables the value of I log 5 to the base 10, I log 3 whole number 1/3 to the base 10, and the I log 0.4 to the base 10. So the question says we should find the values of these figures. Okay, log 5 to the base 10, which is the I log 3 whole number 1/3 to the base 10, and the I log 0.4 to the base 10. We have to find the values of it, given that log 2 to the base 10 equals 0.3010 and log 3 to the base 10 equals 0.4770. Okay, so that's what we are going to do in this video. So let's start with the I. It says we should find the value of log 5 to the base 10. So let me write down my solution and let's do it together. So I have my log 5 to the base 10. Now, before we can get the value of log 5 to the base 10, this log 5 to the base 10, we need to express it in the form where we are going to have the log 2 to the base 10 in it and also the log 3 to the base 10 in it, so that we can substitute our values. I hope you understand up to this point. All that we need to do is that because you have been given the value of log 2 to the base 10 and also the value of log 3 to the base 10, those values are what you are going to use to be able to get the value of log 5 to the base 10. So it means that the log 5 to the base 10, we need to write it in a form that it will either contain the log 2 to the base 10 or the log 3 to the base 10, so that we can substitute our values and simplify. As simple as that. I hope the explanation is clear enough up to this point. So let's go ahead and look at how to write this log 5 to the base 10 in another form, which will contain either log 2 to the base 10 or log 3 to the base 10. And you can see that we can only write it in a form that it will contain log 2 to the base 10. Because this 5, I can easily write it as 10/2. Because 10/2 is 5. I hope you understand and you agree with me. When we have 10/2, when you simplify, 2. When you simplify, 2 goes here 1, 2 goes here 5. So you are going to have 5. I hope you understand. So instead of the 5, I'm going to write 10/2. The idea is to get the log 2 to the base 10 inside. Are you okay with it? So let's go ahead and do that. So I'm going to clean this from here so that we can write this one in another form. So I'm going to write this one as the log of 10 over 2 to the base 10. Okay, so all that we did is to write the 5 as 10 over 2, and I hope you understand and you agree with me up to this point. Now from here, what we are going to do is to apply the quotient rule of logarithm. Okay, and I know by now you understand the quotient rule because we've applied it a lot in the previous videos and we've done a lot of explanation on it as well. Now, just a recap for the sake of those who don't have any idea of the quotient rule. The quotient rule simply says that if I have log s over y, because quotient means division, s over y, it says that I can write it as log s minus log y. Okay, so the log will affect the s, that's the log s. You bring your minus sign, then the log will affect the y, that's the log y. So that is the quotient rule. So we are going to use this rule to write this in this form. I hope you understand up to this point. So let me clean this one and let's proceed. So having log 10 over 2 to the base 10, I can rewrite it as the log of 10 to the base 10. The log will affect the 10. Okay, that's why I have log 10 here to the base 10. Bring your minus sign, then the log will affect the 2 as well. So log 2 to the base 10. Okay, I hope the explanation is clear enough up to this point. So now from here, we know that the log of any number to the base of that same number is always equal to 1. So log 10 to the base 10 is equal to 1. This I've explained a lot in the previous videos. If I have the log of 3 to the base 3, it's equal to 1. That's the log of any number to the base of that same number is always equal to 1. If I have the log of 5 to the base 5, it's equal to 1. If I have the log of s to the base s, it's equal to 1. So in place of this log 10 to the base 10, I'm going to put 1 there. Okay, so let me clean this from here and let's proceed. So I'm going to have 1 minus, now the log 2 to the base 10, its value has been given from the question. Look at it, log 2 to the base 10 is given to be 0.3010. So in place of the log 2 to the base 10, I'll put this value there, which is the 0.3010. And from here, all that you need to do is to use your calculator and let's get the answer. Okay, so I have 1 minus 0.3010, and that is going to give 0.699. So your final answer is going to be 0.699. So that is the value of log 5 to the base 10. As simple as that. I hope the explanation was clear enough and you understood it as well. Let's proceed and tackle the II as well. Okay, so the II, so this is the I. Let's come to the II. So the II, I have the log of 3 whole number 1 over 3 to the base 10. You have to find its value. The first step is that anytime you are solving any question and it contains a mixed fraction, the first thing is to change the mixed fraction into improper fraction. So this 3 whole number 1 over 3, we have to first change it into improper fraction. That's the first step. So I can rewrite this one as the log of 10 over 3, okay, to the base 10. I hope you understand up to this point. The 3 whole number 1 over 3 into improper fraction, you just use the denominator to multiply the whole number. So 3 times 3 is 9, and that's 9, you add it to the numerator. So 9 plus 1 is 10, so 10 all over the denominator, which is 3. So that's why I have log 10 over 3 to the base 10. I hope you understand up to this point. From here, we are going to apply the quotient rule again. So this can be written as the log of 10 to the base 10 minus the log of 3 to the base 10, as we did to this one is the same thing. So the log will affect the 10, that's log 10 to the base 10. Bring your minus sign, and the log will affect the 3 as well, so log 3 to the base 10. Now from here, we know that log 10 to the base 10 is 1, as we did to this one. So the log of any number to the base of that same number is always equal to 1. So log 10 to the base 10 is 1. So I'm going to have 1 minus, then the log 3 to the base 10, its value has been given, log 3 to the base 10. So it's 0.4770. So I'm going to put the value there, 0.4770. Then use your calculator and let's get the final answer. So 1 minus 0.4770 is going to give 0.523. 0.523, and this is our final answer. I hope you understand and you agree with me up to this point. So now let's proceed and tackle the last one, which is the III. Okay, so let me clean this side so that we can have enough space to tackle the III. So the III, I have the log of 0.4 to the base 10. So we have to simplify it. So now the same process, the 0.4, we need to write it in a form that it will either contain the log 2 to the base 10 or the log 3 to the base 10. So the first thing is to change the 0.4 into fraction so that we'll know what to do from there. So let's do exactly that. So now you know that 0.4 in a fraction form is going to be 4 over 10. So I'm going to rewrite this one as the log of 4 over 10 to the base 10. I hope you understand and you agree with me up to this point. All that we did is to change the 0.4 into fraction. 0.4 into fraction is 4 over 10. I hope you understand up to this point. Now let's apply our quotient rule to write this one in another form. So this one is going to be, writing this in another form is going to be the log of 4 to the base 10 minus the log of 10 to the base 10, as we have been doing. The log affects the 4, so log 4 to the base 10 minus the log affects the 10, log 10 to the base 10. That is the quotient rule that you are applying. So if you have division like this, you can express it in subtraction form like this. Okay, so now let's proceed and input. Now before we even input our values, you can see that the question didn't give us log 4 to the base 10. We don't have that. So it means that we still need to do something to this log 4 to the base 10 before we can be able to do our substitution. So now this 4, I will write it in exponent form, which is going to be 2 to the power 2. You know, 2 to the power 2 is 4. So in place of the 4, I'm going to put 2 to the power 2 there. Okay, so let's go ahead and do that. So I'm going to have the log of 2 to the power 2 to the base 10 minus the log of 10 to the base 10. Then from here, we apply the power rule. Remember the power rule. The power rule says that if I have, let's say, log a to the power b, the power rule says that this b, which is here, can come in front of the log to become a coefficient. So I can write it as b log a. That is the power rule which we've established and explained a lot in the previous videos. So that's what we are going to apply to rewrite this one in another form, which means that the 2 here, which is a power, will come in front of the log to become a coefficient. Okay, so let me clean this from here and let's proceed. So I can rewrite this one as 2 log 2 to the base 10 minus log 10 to the base 10. Then from here, I can now substitute my values because I know the value of log 2 to the base 10 and also the value of log 10 to the base 10 is always equal to 1. So let's input our values now. So I'm going to repeat my 2, which is here. The 2 is multiplying the log 2 to the base 10. Take note of that. So I'm going to write 2 into brackets. Then I'll put the value of log 2 to the base 10 there, which is the 0.3010. Then bring your minus sign, then log 10 to the base 10. And the log of any number to the base of that same number is always equal to 1. So log 10 to the base 10 will be equal to 1. So let's proceed and simplify further. 2 times this is going to give, let me continue from this side. You can just put everything on your calculator and write the final answer. So you have 2 times this, which is going to give 0.6020 minus the 1. I hope you understand and you agree with me. Let me write it well so that you can see it well. Okay, good. So here is it. The 2 times 0.3010, it gives 0.6020. Then minus the 1. Then you subtract to get your final answer. Let's do that and see. So I have 0.6020 minus 1, and that gives negative 0.398. So my final answer is negative 0.398, and that is your final answer. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share the video as well. I'll see you again in another video whilst we solve another question on this. Bye bye.